My name is Michiko Hiraoka. The title of my research is Laboratory Detection of Functional Materials in Agricultural Products by using a terahertz wave. This is outline of my presentation. So let me introduce my background of my research. These days, people tend to care about their health, and functional materials are attracting more attention. So there are many functional materials in the world. The isoflavone and anthocyanin are famous. And so far, it's clear that the content of functional materials change during growth. But it's not clear that the relationship between growing condition and the content of functional materials. So, fat condition is the best for growing crops containing much functional materials. So, if we can measure the content of functional material in the field and feed back to the cultivation management, we will be estimate the optimal condition and harvesting time. So now the conventional method for measuring biomaterials are HPLC and ELISA. They are high sensitivity but need complex treatment and labeling process. So my goal is to detect the functional materials in agricultural products without labeling by using terahertz waves. And my target is biotin. Biotin is a functional materials, and the function is keeping skin and mucous membrane good condition. And I use avidin as a protein combined with biotin specifically. So next, I will explain the principle of label-free detection. In conventional labeling method, firstly we fix the antibody on substrate and then at the target. The target combined with antibody specifically, and then at the second antibody with enzyme. When substrate at its enzyme, the color of substrate change by reaction to enzyme. On the other hand, in label-free method, we detect the binding between target and antibody by using transmitting light. By using light transmitting substrate, we use terahertz wave. In label-free method, we can measure. The label-free method is convenient and rapid, but the sensitivity is low. So, in my research, I use two methods to increase the sensitivity. The first is metallic mesh, and the second is reflection interference method. I think you know metallic mesh method very well, so today I will introduce reflection interference method. And in my research, I use a membrane filter as a substrate. In reflection interference method, I sandwich the membrane filter between mirror and the silicon plate. And when the terahertz come in this system, it reflected from the surface of the membrane filter. And this reflected light 1 and 2 is detected. The optical path difference of 1 and 2 is defined as this formula. When the sample attached to the membrane filter, the refractive index increases and the optical path difference longer, and the interference with pattern in frequency spectra change such this. So, by detecting the sample, I will detect the sample attached to membrane filter as a change of the interference with pattern. In previous study, the protein could be detected by using Terhis TDS. In this device, we can get the time domain spectra such as this. And by conducting Fourier transform, we can get the interference with pattern in the frequency spectra. In previous study, they analyzed this frequency spectra, but in my research, I focus on this time domain spectra and analyze this. By analyzing this spectra, I measure the sample attached to the membrane. The reason I use the time domain spectra is to reduce the error. By compensate for this first reflected light, we can remove the device error. So I use a time domain spectra. The next, I will explain two types assay. The first is non-competitive assay. In this assay, we add the biotin solution to the substrate, averaging fixed substrate. The result of the signal amplitude is increase as the biotin concentration. But biotin is small molecule. The change is little, small. On the other hand, competitive assay, we can detect biotin by substituting for averaging. In this assay, we add the biotin solution to the averaging solution with constant concentration. And in this mixed solution, there are free averaging and averaging combined to biotin. And add this mixed solution to the biotin fixed membrane filter. Only free averaging attached to membrane. So the signal amplitude is decreased as the biotin concentration increase. And although biotin is small molecule, we can get a drastic change. So I use competitive assay in my research. So next I will explain my experiment. This is a material and device. I use a nitrocellulose membrane as a substrate. And this is the device I use. The next is method. First, I make the mixed solution of biotin and averaging, and add this mixed solution to the biotin fixed membrane. and I conducted blocking to protect non-specific binding. And after shaking and drying membrane, I conducted transmission measurement. In this measurement, I didn't use the interference system, only measure the membrane filter. Then I conducted reflection measurement using interference system and analyze the spectra in the time domain. This is the result of transmission measurement. And this graph is a transmittance spectra. From this graph, in this graph, the change of transmittance by biotin concentration was within variability. So biotin from 0 to 2.5 microgram per milliliter couldn't be detected. And the next is the result of reflection measurement using interference system. This is a time domain spectra of membrane filter. I fix the spectra by using the Lorentz function and detect the peak 1 and 2 and calculate the time delay. I check the change of time delay by biotin concentration. This is a graph. This is a change of time delay by biotin concentration. In this graph, time delay decreases with the increase of biotin concentration, and biotin from 0.5 to 1 microgram per milliliter could be detected by using interference system. But the problem is variability, big variability. And I think the cause is a difference of attached abyssine amount between membranes, and abyssine may fall from membrane filter during bossing. So this is final slide. Conclusion. I conducted detection of biotin by using terahertz interference system combined with competitive assay. As a result, biotin from 0.5 to 1.0 microgram per milliliter could be detected without labeling. So now I try to detect the biotin in extraction liquid and then compare our system to the conventional HPLC. And in the future, if we can develop the system using single beam, we will be able to make small device a farmer can use in the field. That's all.
Question? Question?
I want to know why your study has to be used conducted in terahertz solution. Why you use terahertz time domain pulse?
Time domain pulse. はい。In fact, the terahertz wave reflected in membrane filter many times, and this is the content of multiple reflection. In multiple reflection, have information, not only membrane filter but also silicon. But I want to know information in only membrane filter. So I remove this multiple reflection. So by using terahertz time domain spectroscopy, I can delete this multiple reflection. So I use terahertz
But there are
time domain.
time domain pulse of infrared vision or visible vision has been much more developed and maybe more accurate. But why you chose the terahertz vision?
Terahertz vision.
Advantage.
The reason I use terahertz vision is terahertz wave transmit the membrane filter. So I use terahertz vision.
So if you use infrared vision and the transparent sample, if you put a transparent sample, that may be more easier to detect the smaller things like biotin. Biotin size is
Biotin size the molecular weight is 244. 44.
micron. What the size?
Size Angstrom.
Angstrom. Yeah, depends on the Angstrom is to the 8th power minus 8th power Angstrom. Nano is the 9th power.
Nano.
Micro is the 6th power. Nano.
No, I don't remember.
Oh, you don't? Okay. You have to defend about this question.
はい。
Sorry, I have.
Okay, later. Okay, please.
I don't understand. Your graph is showing reflectance, the diagram, but the graph showing the transmittance. Can you explain?
In fact, we detected reflected light, but this second reflected light is
The green one?
considers the membrane filter and reflected mirror.
Oh.
So, in fact, we get the information in this membrane filter. So, although we detected the reflected light, I showed in this research, they show transmitters.
So the green line is transmitted to the sample and all 100% reflected by silicon. That's silicon, the blue one. But it go twice on a tray twice.
Yes, and in fact, the light reflected second and third, and this
Vibration.
and the first reflected light is reflected second and third. So don't use this. I don't use derivative light from silicon. So I use only this reason for analysis.
Not easy for audience to understand about those. Maybe a little more change something to make simple. Anyone suggest? Then actually, what do you got result and conclusion again? Show us. That biotin 0.5 to 1.0 microgram, I mean, was okay. More than that or less than that, not easy to detect. Without labeling.
Not difficult. And the metabolic mass is more sensitive than this.
You compare with the metabolic mass. But it has another advantage. We don't need the metabolic mass, just TDS.
Yes.
Any questions? Okay, thank you very much.